Hi, my name is Jeff Swift. I'm a last semester computer science student, and under the supervision of Dr. Gurmukh Singh, I researched algorithm development in C# and Visual Basic for projectile motion simulation. So this research is based on some research done by my faculty mentor Gurmukh Singh with Khalid Siddiqui, and their research was in teaching physics and science through Microsoft Excel. The beauty of Microsoft Excel is you can just input an equation and it will generate many values for the equation you want to model. Now, in addition to the operating systems that Windows produces, they also produce this software called VisualStudio.net. And VisualStudio.net is interesting because it makes it really easy for a programmer like me to create a graphical user interface, or GUI, and attach code to it. And that makes it also ideal for modeling physics equations. These equations basically come from, if you've ever taken a physics intro level course or a calculus course, they're basically just involving simple velocities, being change in position over time, and acceleration. It's the change in velocity over time. From that, we get equations that allow us to track the position of a projectile in 2D space based on time that's elapsed and things like its starting positions and velocities. The project that I undertook was modeling these equations through the code in two different languages, Visual Basic and Visual C#, which are both included in the Microsoft Visual Studio software. Some of the features I included are the ability for a user to input the starting positions, the starting velocities of the projectile, the frequency at which you wanted to generate data points, so that could be every second, every tenth of a second, every hundredth of a second, and then I put in a little bit of custom gravity, so you can actually specify whether you want it to simulate Earth gravity, or you could very well simulate throwing a ball on Pluto through the air. So what we find is that the gravitational acceleration directly affects all this data, and it's quite different when you introduce different gravity. It's the same sort of arc of motion. You have different slopes, different values, and it's capable of outputting these in the form of charts, text files, and in the form of the in-application list of all these values. So now we can see all this data generated in real time using the software that I built in Visual Studio. So this is the application filled in with some sample data. We'll be looking at a time window of 100 seconds taken at 10th second intervals. The projectile will start at 0 along the x-axis and 1500 along the y-axis. The initial x velocity is 30 meters per second, and the initial y velocity is 500 meters per second. So now we hit simulate, and we see after a couple seconds it has generated about 1,000 data points along the simulation that show the x position, y position, x velocity, and y velocity for any 10th second increment. And if you want a graphical representation of it, you just click Show Charts, and you get a variety of charts showing the height of the projectile over time, the height of the projectile over the distance, the instantaneous x velocity, and the instantaneous y velocity. So we find through this research that VisualStudio.net 2012 provides a really easy and efficient way to model natural physical phenomenon and the motion of a projectile through 2D space.